to BKW Physics. I'm Mr. McConley, and we're going to go through a demonstration today to take a look at the way projectiles fly through the air and the optimal angles. So what I have here is a projectile launcher. It fires these wooden blocks, and I'm going to fire these at 3 different angles, and my assistant is going to mark on the table where the projectile first hits the table. So the first angle I'm going to project at is 70 degrees, so a very steep angle. Okay? If it misses the table, yeah, just come basically close. Now I'm going to drop it down. I'm going to go at 20 degrees. So here's 20 degrees. Alright. So you got 20 degrees, 70 degrees, and the last angle I'm going to choose is a 45. So at 45 degrees, ooh, you can see at 45 degrees we gained a lot more distance in comparison. The 45 went out to here, where the other 2 were grouped back here. Now 70 is a pretty high angle, but let's take it to even a little bit further of an extreme. What if we were to fire it straight up in the air at 90 degrees? Where would it go? Well, obviously, it would go straight up in the air, and it would come straight back down. So its distance would be 0. If we were to fire it, I can't even get it all the way down, but if we were to fire it at ground level, then basically as it left, it would be hitting the ground, and its distance would be 0. So you can see why the optimal angle is exactly in between at 45. These are the 2 worst case scenarios in terms of distance. 45 is going to give you the furthest distance. The last thing is, which one of these distances will actually give you the most time in the air? Let me say it this way. If we know that 45 will go the furthest, and then we go to 70, and we realize that 70 made it arc in the air higher, which one of them actually stayed in the air a longer amount of time? So let's watch it one more time. This time we're not concerned with how far it goes. We're just kind of mentally timing, if you can think like 1 Mississippi, 2 Mississippi as it's flying through the air. So watch the 70. Okay, you kind of got a visual on that. In comparison, if I shoot it somewhere around the 45, which one to you appeared to stay in the air longer? The higher arc seemed to be staying in the air longer. Okay? So those are the few things that we're talking about with projectiles. Now what we're going to do next, on the next video, if you tune back in next time, we're actually going to get the speed as the projectile is leaving the launcher. We're going to record the speed with a timing device, and then given the angle and the speed that it left, you at this point as a physics student should be able to calculate how far it's going to go, how high it's going to go, the time it's in the air for, the vertical velocity and the horizontal velocity, all from those 2 pieces of information. So for this time, physics.